So hello and welcome to this video series where we will understand what is a voltage, current and a resistance. So we describe those parameters within a circuit in a simple term where one can understand. So firstly, let us define what is a voltage. So a voltage is nothing but a pressure that is from a power source that pushes the electrons. So one can define the voltage as a force. So we all know that in order for a work to be done, there needs to be a force. So in an electrical circuit, there must be a force that makes the circuit to work. So this force is known as the voltage. So there are two types of voltage. So the one can be the DC, or we call it the direct current, and the second one is the alternating current. So in some other definition, a direct current can also be known as a direct voltage and alternating voltage. So those are two types of the voltages that we have. So now we can look at where can we find those type of voltages. So let us start with the DC voltage. So the DC voltages can be found from a battery. So a battery is a voltage source that produces direct current. And if you can also remember, if you have a solar panel, it can also be the source of producing a direct current, or the other example can be a power supply, a DC power supply. So it is capable of producing direct current, so you can connect it to the positive and the negative terminal of your circuit, and it can be able to produce the required DC or the direct current. So how about the AC voltages? Where can we find AC voltages? So if you have a house, you know that from the GPO you can have a 240 volts output that we normally connect to our computer, our laptop and so forth. And the other one is the AC generator. So in this AC generator, you have a 2-port that you can connect to your AC appliance, or you can connect to oscilloscope to see the change in the alternating current. So those are the sources, we can say the sources of the voltages. So we have DC and AC voltages. So now let's look at the difference between the two in terms of the waveform diagram. So with the waveform diagram, it is very easy for one to study and identify those two types of voltages. So for the DC voltages, we can see the waveform in terms of its graphical representation, where we have the amplitude with respect to the time in seconds. So the amplitude is in terms of the voltage. So since it is called a direct current, that means there is no change in the waveform. So that means this represents the direct current or the direct voltages. So that means if we have a 5 volts, that means with respect to now and into the future, it will be 5 volts no matter what. So now, tomorrow, the day before tomorrow, maybe next year, 100 years from now, the amplitude will remain the same. So this is known as the direct current. So this is the waveform. So how about the AC voltages? So in AC voltages, we can see from the diagram, it also has the amplitude, which is in terms of the voltage, and we have the time, which is in seconds. So in AC, since it says it is alternating, so that means alternating between what? So alternating between the positive and the negative. So if we have a sinusoidal waveform like this, so we can see if this is, for example, 5 volts and minus 5 volts AC. So that means every time the source will alternate between positive 5 volts and negative 5 volts. So it is alternating every now and then. So that means today it is alternating, tomorrow and maybe 10 years from now it will still alternate. So in that case, we can see that this is the current which alternate, and from here we can also see the current which is not alternate. So this is the basic difference between these two type of sources. So this one, it will be positive throughout, and this one will be alternating to positive and negative. So in that case, we can see the difference between the two. That means for the AC, what do you think will happen to these AC voltage sources? Because from the DC, we can see that the terminal, if we have positive 5 volts, that means the terminal must be specified. So the terminal must be specified. The positive must always be connected to positive, and negative must be connected to negative. But in terms of the AC, when you look at in terms of the terminal, there is no direct positive or negative, because every time it is changing. So if you have to measure, for example, the AC, there is no specific terminal. That means that the polarity is not specified for the AC. You can connect the maybe a voltmeter to positive terminal or negative terminal, nothing will change. So this is the idea behind what is a DC and what is the AC voltage.